Hello, in this video I'm going to show you a proof that shows that 0 does not exist. Obviously this is not a real proof and there is a mistake somewhere in this proof. As you watch this video, see if you can find the mistake, and at the very end of the video I will do my best to try to explain where everything falls apart. So we're going to start by writing just the number 0 down, and we're just going to directly show that it does not exist. So 0 is equal to, and we're going to use some calculus here. So if you don't know calculus, I'll do my best to explain. This is equal to the limit as x approaches 0 of 0. So what is this? When you're looking at the limit of 0 as x approaches 0, you're asking, as x gets really close to 0, what happens to 0? Well, it's just 0, so it's going to be 0. In general, when you have the limit of a constant, which 0 is a constant, you're just going to get a constant. So this is equal to this. And the next step is really interesting. Now we're going to introduce some funny stuff. So we still have the limit sign. So now I'm going to write 0 in a clever way. I'm going to write it as 1 over x minus 1 over x. Just like that. And this is also okay, right? Because I haven't really done anything other than write 0 as 1 over x minus 1 over x. So if you subtract 1 over x from 1 over x, you're just going to get 0. So all of this is okay. In the next step, we're going to break this up into two separate limits. So we have the limit as x approaches 0 of 1 over x, and then minus, so we're going to bring down the minus, and then we have another limit, right? Just breaking it up using properties of limits, approaches 0 of 1 over x, just like that. So just breaking up the limit of a difference into two separate limits. And so now we're going to try to think about what these limits are. So I'm going to come down here and do a little graph for you. So there's the y-axis and there's the x-axis. And we're going to look at the graph of 1 over x. Y equals 1 over x. And then here's the y-axis. So this graph has two asymptotes. It's got a vertical one here, and it has a horizontal one here. And it looks roughly like this. This is a pretty rough picture here. And like this. And so when we're trying to evaluate the limit as x approaches 0, we have to think about what happens to the graph when x gets really close to 0. So we can do that by thinking of what's called one-sided limits. So if we look at the limit from the right, so as x approaches 0 from the right, you see the arrow here is me indicating that x is approaching 0. The y value goes up forever. It shoots off to infinity. So the limit as x approaches 0 from the right of 1 over x, well, it's going up forever, so that's equal to infinity. Okay. In this case, we would say the limit does not exist, but infinity is just a more accurate description of what's happening. So we write infinity rather than does not exist. Now let's look at the limit as x approaches 0 from the left of 1 over x. So again, approaching 0 from the left, what happens to the y values of the graph? Well, as x gets closer and closer to 0 from the left, the y values get infinitely small. So we say that they are approaching negative infinity. In this case, the limit also does not exist, except we write negative infinity because it's the more descriptive option. So whenever you write infinity and negative infinity, those limits still don't exist. It's just we're being more descriptive. We're trying to describe the behavior of the function in a better way. So because this one approaches infinity and this one approaches negative infinity, what do we do for the regular limit or the two-sided limit? Well, in this case, we really can't say anything about this. So this limit here, the limit as x approaches 0 of 1 over x, This limit does not exist, so we write that as DNE. But neither does this one, so none of this makes sense. So none of this exists. So this does not exist. So we have just shown using calculus that the number 0 does not exist. And that means that the world will implode upon itself, whatever that means, or that there is a fatal flaw in this really simple argument. And there is a fatal flaw, and it's a very instructive flaw. Out of all of the little trick problems out there in math that show that 1 is equal to 2, that pi is equal to 0, in my opinion, this is probably the most instructive one. And so I'm just going to go ahead and tell you right away what the mistake is. The mistake is right here. You are not allowed to do this because you're going from something that doesn't make sense to something that makes sense. You may say, wait a minute, we went from here, from the bottom up. It's got to go both ways. It's an equality, right? So you're also going from the bottom up, right? Rather, we went from the top down, but you have to think about it going the other way too. From this step to the step above it has to make sense. And it doesn't, because neither of these exist. If you recall from calculus, if you've taken calculus, or maybe you will be taking it, there is a statement that says if you have a limit as x approaches c of f of x, and this exists, in other words, it's equal to a number, and if you have the limit as x approaches c of g of x, and that also exists, in other words, it's equal to a number, then what happens is you can look at the limit as x approaches c of the sum and difference, so f of x plus or minus g of x, exists. So if the individual pieces exist, so if the limit as x approaches c of f of x exists, and the limit of g of x as x approaches c exists, then the sum and difference also exist. But that's not what we did here. Right here, we had two limits that did not exist, and we went to something that exists. So you can't do that. You might think, well, wait a minute. This is saying that if this exists, then the individual ones exist. That is not true. This is an if-then statement, so it only goes one way. Again, if the individual limits exists, then the sum and difference exists. If the sum and difference exist, there's not necessarily true that these exist. In fact, in this example, we showed that even though this is 100% equal to 0, this does not make any sense, right? None of this makes sense. So just because you have something that exists as a whole doesn't mean that the separate pieces are going to exist. The separate pieces must exist, and then and only then can you combine them into a single piece and say it exists. So hopefully that made some sense. It's a really crucial idea, especially if you do any type of proofs. If you take a class called Advanced Calculus, or sometimes it's called Real Analysis, this is one of those things that you can easily misuse this and mess up in your proofs. In fact, that's where I learned this. I learned this in an Advanced Calculus 2 class. And I remember the day I learned this, looking at the board and being in awe and thinking, oh no, my homework is wrong. So hopefully this video has shown you that 0 does exist, right? Because 0 does not exist is a false statement. So 0 does exist, and hopefully you've learned a little bit of calculus. I hope this video has been helpful, and maybe now you can show it to other people and see what they think. Good luck.